Yeah. Sorry, there was some network issue in the college. Okay, yeah, we'll continue. Presentation गया क्या मेरा? Presentation है? Can you see the presentation?
No,
No.
ma'am.
No, ma'am.
Yeah, I'll just share once again. It is visible properly.
Yes, ma'am.
Yeah, yeah. So the second type is coaxial cable. इफ देर इज एनी इशू, हाँ अगर वापस नेटवर्क चला जाता है या आपको कुछ वॉइस ब्रेकिंग हो रहा है तो प्लीज़ इन्फॉर्म मी, और अगर मेरा नेटवर्क ही गया है तो प्लीज़ पुट द मैसेज इन द व्हाट्सएप ग्रुप. ओके, या सो yeah, coaxial cable. So the second type of transmission medium is coaxial cable. All of you must have seen this, which the wire which is used to connect your TV cable. Okay, so coaxial cable, it consists of two conductors. You can say this is the inner conductor and this is the outer conductor. So the inner conductor is held inside an insulator with the other conductor woven around it, providing a shield. So this is the inner conductor. These are the insulators. So this is the insulator which is covering this inner conductor. Around after this, there is a outer conductor which is there, and again there is a insulator, and then there is a plastic cover. This is helping in reducing the interference. And insulating protective coating called as jacket covers the outer conductor. The outer shield protects the inner conductor from outside electrical signals. The distance between the outer conductor and the inner conductor plus the type of material used for insulating the inner conductor determines the cable properties or its impedance. So there are different categories. Uh, just 1 minute. Hello. Yeah, sorry for the disturbance. Uh, Hello.
Yes, ma'am.
Yeah. So okay, so coaxial cable standards, you have different categories, RG 59, 58, or 11. And depending upon that, like different, here we have seen there is a different properties or different inter impedance. Okay, so depending on that, there are different impedance wires, different characteristics. So the applications are also different. You have cable TV or thin Ethernet or thick Ethernet. There are different kind of connectors which are used. We have used, see here, we have seen the RJ45 for UTP. So here there are different kind of connectors which are used for coaxial cable. This is BNC-T. To connect coaxial cable to devices, we need coaxial connectors, and most common type of are these BNC connectors. Uh, BNC connector, BNC-T connector, and BNC terminator. So this is BNC connector. This you must have seen when you are using it for the cable TV. This is BNC-T connector, and this is BNC terminator. Applications, you must have seen it is for TV that is a aerial to TV and cable TV also. Long distance telephone transmissions, this can be used. Uh, it can carry 10,000 voice calls simultaneously, but now it is replaced by fiber optics. Short distance computer system links, LAN, uses these coaxial cables. It can be analog or digital. If it is analog, amplifiers, even every few kilometers, uh, up to 500 megahertz can be used. Digital repeater, when you have used digital, the repeater is like the distance which it can carry is reduced. Then high bandwidth and higher data rates. Next is the optical fiber. In optical fiber, there is a there is a core, there is a cladding, and then there is a jacket. So optical fiber basically uses light as the transmission medium. So there are different grading indexes for this whatever material is used for core or for cladding. Okay, so there is a glass or plastic core, and then there is a laser or light emitting diode. Uh, you have a specially designed jacket for this. They are small size and weight. How it transmits is this is a light source. It is reflected through this core, and there is a cladding. So if even if any light is escaped from this core, okay, it is again uh, there is a reflection and refraction. Okay, so this the light travels through this core with the reflection. And if anything is light is refracted, there is a shielding outside so that it should not be escaped. So there is some angle, critical angle of reflection. So this is how it works. If the angle of incidence is less than critical angle, so this is less, then the ray will be refracted. Okay, that means it will be escaped out of the medium. So the core and cladding, the grading index is different. This is more dense, this is less dense. Now, if the correct angle of like incidence is equal to critical angle, then it will be traveling through this. Thus, it will be absorbed. Okay? But if you have the angle of incidence, which is more than the critical angle, so this is the angle which is more than this critical angle of incidences, then there is a total reflection. So for optical fiber proper working, this is required that the entire whatever is the incidence light, it should be totally reflected. Okay, it should not be refracted or it should not be absorbed. It should be totally reflected, and this has to be done at all the boundaries. Okay, so every boundary, whenever the light is incidence, it is totally reflected, and this is how it travels. Okay, there is a reflection, total reflection over here. There is total reflection over here. So like that, it travels from source to destination. Okay, so this is how it works. So optical fiber benefits, it is having greater capacity. So if you compare it with coaxial cable or compare it with twisted pair, the first thing is like there is no electrical signal traveling. So there is no electromagnetic interference. Okay, so all the problems of electromagnetic interference and crosstalk are avoided. Okay, they have higher capacity, so the transmission now you can see uh, all the like in your network, all the cables are replaced by fiber optic cables. Okay? So that we are having a data rate higher, the bandwidth is more, so it can provide data rates of hundreds of Gbps, the greater capacity. Okay? That is a major benefit of optical fiber. It is smaller size and weight, lower attenuation. There is no electromagnetic interference, so there is electromagnetic isolation. Greater repeater spacing, that is the distance can travel to more distance. So the number of repeaters are reduced. So uh, the repeater distance is increased. Applications is long haul trunks, metropolitan trunks, rural exchange trunks, subscriber loops, and LANs. So you can see that major like telephone lines now are replaced. Basically, the Geo network they have implemented. Reliance has changed the entire like network technology, transmission technology. They have changed the entire thing to optical fibers. And these are the characteristics. It acts as a waveguide for 10 raised to 14 to 10 raised to 15 hertz. Then it uses this, since it uses light. Okay? There are which are cheaper, wider operating temperature range, last longer. Or there are ILDs which are more efficient and they can provide greater data rate. Okay? There are different kind of transmission modes. You have step index, you have graded index, and there is a single mode optical fiber. And now we need not go like we will not go into the more details of optical fiber. You will be like you can learn it in the particular subject OFC, that is optical fiber communication. Now here we just have to give the idea as how the optical fiber transmission is done. So we won't go into the more details. So there are different wavelength and different frequency ranges which it can handle, operates in different various bands, and the applications. So depending upon whether it is multi-mode, single mode, and what kind of frequency range it operates, the applications are it can be used in LAN, it can be used in this uh, wavelength division multiplexing, WDM. Now this was regarding the wired mediums. We have seen twisted pair, coaxial cable, and optical fiber. We have seen these three. Now next is the wireless transmission medium. So wireless transmission medium, we know that electromagnetic spectrum. Okay, it is generally wireless transmission means you will be using different electromagnetic waves. So you have microwave, you have infrared, there is radio frequency, RF signals. Okay, so this is the range 2 gigahertz to 40 gigahertz. You have microwave, highly directional point to point. You have satellite communication in this range only, 30 megahertz to 1 gigahertz. It is the broadcast radio, which is omnidirectional. You have this 3 into 10 raised to 11 to 2 into 10 raised to 14. You have the infrared or local. So this is the electromagnetic spectrum. It is divided. You have long wavelength, short wavelength. The useful is microwaves, radio waves, short and long radio waves, and infrared. So you'll be seeing these three as the medium for uh, electromagnetic waves which are used for transmission. Again, the wireless propagation, it can have three routes. Signal travels through three routes. You have ground wave propagation, sky wave propagation, and line of sight propagation. Ground wave propagation. So ground wave propagation means, say for example, this is a transmitter, this is the receiver. Ground wave propagation is below 2 megahertz. This is the signal propagation along the line of the like earth surface, along the earth surface, ground wave propagation. So it follows the counter of the earth. It is up to 2 megahertz, and AM radio this uses this ground wave propagation. You have sky wave propagation. sky wave propagation is this. Actually, this is the ionosphere, and this is the transmitter, this is the receiver. Now these ground wave and sky wave, they come into picture when there is a no line of sight propagation. Okay, suppose transmitter and receiver, they are in a line of sight, then there is a line of sight propagation which is above 30 megahertz. So this transmitter antenna and receiver antenna, they are in the line of sight. So this is a line of sight signal propagation. When they are not in no line of sight, then there can be a ground wave propagation or sky wave propagation. Okay. Now in ground wave propagation, signals below 2 megahertz can travel along the surface of the earth. So it is a ground wave propagation. And above that particular level, there is an ionosphere. Like the environment of the earth is also used for transmission. That is, there are signals which you can transmit, and there is a ionosphere which through which you can have the reflection. Okay. So this transmit signal will be reflected from the ionosphere, and the signal wave propagation can happen till the receiver antenna using the sky wave propagation. Okay, so amateur radio and BBC World Service, these all use the skywave propagation. So signal is reflected from ionosphere, which is the layer of upper atmosphere. And line of sight is about 30 megahertz. It may be further than optical line of sight due to refraction. So there is a ground wave propagation, sky wave propagation, and line of sight propagation. There are different radio frequency bands. Say when you are using this radio frequency, you are using from 3 kilohertz. Okay, so these are different kind of radios which are used at different you can use at different distances. So radio waves from 3 kilohertz to 1 gigahertz, microwave from 1 to 300 gigahertz, infrared from 300 to 400 300 gigahertz onwards, wavelength is 1 millimeter to 770 nanometers. So radio waves, all of you know, we are using, like there can be AM radio or FM radio, and these radio waves are omnidirectional. Okay, omnidirectional means they are not directed to one particular direction. Antennas, they can be present. Omni is all everywhere. So can have radio waves present everywhere. They can penetrate through walls. AM radio can receive signal inside the building. There is no isolation of communication, but it suffers from multipath interference and reflections. That is, whatever radio waves you are transmitting, they can be reflected. They can be reflected from various buildings. There are a number of obstacles. You have trees, you have various you can say mountains are there. There are like natural resources are there, or some man-made resources are man-made made buildings or obstacles can be there. So it suffers from that reflections. So there can be a multiple copies of the signal which can be present at the receiver. Okay, through multiple reflections, there is a multipath interference. That is, there are a number of other like noise gates added. You must be knowing about AWGN or other type of noises. So there is a multipath interference basically which is added to this particular radio frequency waves. And it uses omnidirectional antenna. So antennas is you must be knowing antenna. You have subject antenna this year only, no, or next this year only. Yes. So you have electrical conductor. Antenna is an electrical conductor which is used to radiate electromagnetic energy or to receive, either transmit or receive. So radiate or collect electromagnetic energy. Transmission is radio frequency energy from transmitter. It will be transmitted, converting that electromagnetic energy like whatever signal it is receiving, that will be converted to a electromagnetic energy by antenna, and it is radiated into surrounding environment. Reception means whatever electromagnetic energy is incident on that particular antenna, that will be converted to the radio frequency electric, like converted to that waves will be converted to a electrical energy, and it will be transmitted further. So it is fed to receiver. Now we are using same antenna generally for transmission and reception. There are no two antennas, one will be transmitting and one will be receiving. There will be one antenna only which will be used for transmission and reception. We have microwaves. These microwaves are unidirectional. Here there are again different characteristics for microwaves. The antennas need to be aligned, and the propagation is line of sight for microwaves. Okay. They are very high data rate, very high frequency signals, but they cannot penetrate through walls. They are absorbed in rain. Okay. So applications is it can be used in cellular phones. There is a unicast communication. Unicast is one to one. Satellite networks, wireless LANs. This is one of the type of antenna, parabolic reflective antenna. There is a terrestrial microwave which uses this parabolic dish. It has focused beam, line of sight, long haul telecommunications. Higher frequencies give higher data rates. Satellite, when you have satellite communication, satellite is a relay station, receives one frequency, amplifies and or repeats the signal and transmits it at another frequency. So when you are using satellite, you have generally the like uh, it receives at one particular energy or one particular frequency, and it transmits it on another frequency. So the same antenna, there is no mixing of the signals. Okay, transmitted signals and receiver signals are not mixed. Transmission at different frequencies and reception at different frequencies. It requires geostationary orbits. Will be used in television. Now all of you know that TV has their satellite antenna. You have long distance telephone which will be using the satellite communication. You have many private business networks which uses satellite communication. So this is the earth station, and earth station will be transmitting. This is a satellite antenna, so it will be receiving and it will be transmitting at a higher frequency. This is a point to point link, or there can be a broadcast link. So there can be one transmitter and there can be multiple receivers. Okay, this is the broadcast link. The next one is infrared. It's a short range communication. Modulate non-coherent infrared light. There is a line of sight transmission used. It is blocked by walls. You have TV remote control or IRDA port. Your remote control uses this infrared. So if there is any obstacle between that transmitter and receiver, you know that your remote won't work. Okay, so there is a line of sight communication required. They have to be aligned, like same transmitter and receiver has to be aligned. They are blocked by walls or they are blocked by obstacles. They cannot pass through that obstacle. So there is a infrared, which is a short range communication. You know the range of the remote TV remote. Okay? So very short range communication. Okay. So these are some of the transmission mediums which are used. Okay. Okay. Now. Okay. Any doubt in this particular topic for transmission mediums?
No, ma'am.
Pardon? No, na? Okay. So I'll just take your attendance. And actually, Shweta ma'am is stuck in traffic. She has not yet reached college. So I have taken her lecture for of 9:15. Today you won't be having IPMV lecture. स्नेहल मैम won't be taking. So मैम का lecture श्वेता मैम लेने वाले थे, लेकिन श्वेता मैम अभी तक पहुंचे नहीं है. So I have taken this extra lecture, and ma'am has told me to continue with my lecture, that is second lecture also. Okay, so अगर वो तब तक आ जाती है, then she will be taking. Otherwise, I am only going to continue with CCN. So right now, what I will do is I will just take the attendance, and I'll give you the break. And then if she doesn't turn up, I will start at 10:20 again. Okay, so same meet.
Ma'am, hello. Ma'am, she has messaged in the WhatsApp group to continue.
Yeah, she has told me to continue. That's what I'm telling. अभी तक वो पहुंची नहीं है. So right now she has told me to continue with the lecture. जब भी वो पहुंचेगी, ma'am will continue with her lecture. That's what she has informed me. So right now what I will be doing is I will be taking your attendance and I'll be giving you the break. हम break लेंगे 5-10 मिनट का, and after 5-10 minutes we'll again continue. Okay, मैं attendance लेके अभी मैं break ले रही हूँ. Okay, we'll take some break of 5 or 10 minutes. 5 minutes only.
Okay, ma'am.
Yeah, I'll take the
Okay, ma'am.
attendance. Attendance लेती हूँ मैं, रुको. Or what I will do is I will just download the meet attendance right now. Okay, no problem. I'll take the attendance. नहीं, लेकिन सेकंड लेक्चर में कोई ज्वाइन हो जाएगा ना. रुको रुको. I'll take the attendance only. Wait. Okay, I'll just read from the meet. 3, 4, 5, 6, 7. 3 to 7 are present. If anybody else is there, please inform me. Then next is 9, 11, and then 13 to 16. 9, 11, 13, 14, 15, 16. And I can see 18, 20, 22. 18, 20, 22. 23, 24, 26, 27. 23, 24, 26, 27. 28, 29, 31. 28, 29, 31. 33, 34. 33, 34. 36, 38. 36, 38. 43, 44, 45, 46, 47, 48, 43 to 48. Fifty-eight, 51, 53, 51, 53, 57, 58, 60. 7, 58, 60. Sixty-one, 63, 68. 61, 63, 68.
मैम 66
66 किधर दिख नहीं रहा है मुझे, कौन है, नाम क्या है?
B25 I
वैसे
forgot to change
B25
my
मत
name,
करो
sorry.
अभी, आप अभी ना, अभी आपका जो रोल नंबर है ना उसके हिसाब से आप नया ये ज्वाइन कर दो। हाँ, ये
Yeah,
B02
ma'am.
कौन है? B02 एंड B25।
Yeah, ma'am. I'll change.
25 is 66। ओके, तो आप 66 नंबर से ज्वाइन हो जाओ अगली बार से।
Yeah.
एंड 2 कौन है? नैनिश, इसका नंबर 2 ही है क्या? ओके ओके, right now I have just taken the meet attendance here. I'll see the timing. See, yesterday also there were some students who have joined for, I have given the instruction 5-10 मिनट के लिए अगर ज्वाइन होते हो तो मैं अटेंडेंस नहीं लगाऊंगी, though your attendance is reflected in this thing. So right now I have just taken the meet attendance and I have marked, but I will be checking the timings and then I will be correcting that attendance again. Okay, yeah, so you can just
Ma'am,
have the
7.
break. हाँ,
7, 7.
लिया मैंने सबका। हाँ,
मैम
लिया
रोल
मैंने, यहाँ
नंबर
पे जो भी प्रेजेंट दिख रहा है ना सबका लिया। 3, 4, 5, 7, 9 सबका लिया है। यस यस,
Thanks, ma'am.
मैम फिर लीव होने का है कि यही लिंक पे वेट करने
नहीं,
का है?
यही लिंक पे ज्वाइन होने का है। आई एम कीपिंग दिस लिंक ऑन, बट वी विल हैव अ ब्रेक ऑफ अभी 10:14 हुआ है ना, आई विल बी ज्वाइनिंग बाय 10:20। 5 मिनट्स का ब्रेक लेते हैं एंड देन अगेन